question 3 part A, which is the question achieve if fault happen at bus 2 through a fault impedance which is given ZF equal to 0.0255 I per unit. So firstly, we need to redraw the bus power system. There is 4 bus in the power system. So before we calculate the bus impedance, we need to identify what bus is connected to the bus 1, bus 2, bus 3 and bus 4. So bus 1 is connected to bus 0, bus 2 and bus 3. While bus 2 is connected with bus 0, bus 1 and bus 3, and bus 3 is connected to bus 1, bus 2 and bus 4, and for the bus 4 is connected with the bus 3. So before we calculate the Y11, Y22, Y23 and Y44, we need to calculate the Y10, Y12, Y13, Y20, Y23 and Y34. How to calculate? We need to divide it by 1 over the value of the per unit. Next, we can calculate the Y11 by adding all the buses that connected to bus 1, which is we get negative I 9.5, and for the Y22 we get negative I 8.187, and Y33 we get negative I 13.593, and Y44 is negative 5.263. And for the off diagonal bus, we can calculate by inverse the Y12, Y13, Y23, Y34, which is Y12 equal to 1 and we get I2, and Y13 and equal to Y31 equal to I5, and Y23 equal to Y32 equal to I3.33, and lastly Y34 is equal to Y43 and equal to 5.23I. And I will pass the floor to the next presenter to explain about the admittance matrix.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Shabibadno and I will continue the explanation for question 1. So after we've obtained all the necessary components for Y, we have Y11 until Y44. We plug in all the components into the admittance matrix Y, and we can see that it is a 4 times 4 matrix. And from all of these values, we need to bring out the negative J outside of the matrix bracket. And using this matrix, we need to inverse the Y admittance matrix is in order for us to evaluate the Z impedance. So with inversing the Y admittance matrix using calculator, and the negative J outside of the bracket automatically becomes J due to the inverse, and we automatically have the Z component for this circuit. And then after we've obtained the Z component, we have to evaluate the fault current from the circuit, which in this question the fault occurs at bus 2 by evaluating the fault current using formula of I2F equals to V2 naught over VZ22 plus ZF, and V2 naught is usually with assumed as 1 per unit. Z22 from the Z impedance matrix, we have the value of J 0.2275, and Z fault from the question mentioned J 0.0225. And after we calculate, we have the I2F or the fault current at bus 2 is negative J4 per unit.
Thank you my friends for the fault current that was obtained. So from the fault current, we can find the bus voltage by using the formula of VI fault equals to VI initial minus ZIK and times fault current. Okay. So from the equation, we got the voltage for bus 1 equal to 0.44 pu. Then for the second voltage, which is the bus voltage at the second bus, is 0.09. For the third voltage, 0.3 pu, and the fourth voltage is 0.3 pu. Okay, so then we can find the line current during fault using the bus voltage by substituting the bus voltage into the equation of Iij equals to VIF minus VJF over Zij. So after substituting the bus voltage into the formula of line current during fault, we got the line current for I12 equals to minus 0.7 pu. For the line current during fault in 1-3, we got minus J 0.7 pu. Also for the current I3 3 to, we got the current is negative J 0.7 pu. But for the current in bus from 4 to 3, we got 0. So from the equation, we have solved this problem, which is the bus voltage and the fault current. Thank you.
Assalamualaikum, my name is Uminah Daya. For question B, the first step is to find the Thevenin sequence impedance for the fault happen at bus 2. As mentioned in the question, the reactance is in per unit, referred to the common base. I will explain the positive sequence and negative sequence network. First, convert all the parameters into circuit configuration as shown in this slide. For positive reactance sequence, we need to include all the parameters that including the voltage source of the generator in the equivalent circuit, but for negative sequence, the voltage source is neglected. As fault happen in bus 2, the ZTH at bus 1 is parallel to ZTH at bus 3. As the result, the ZTH at bus 1 is equal to J0.3, while ZTH at bus 3 is equal to J0.65. The Thevenin impedance for the positive sequence is equal to 0.2275 per unit. As I mentioned before, the difference between negative and positive sequence were at the circuit drawing, which is no voltage source for negative sequence. So the total Z Thevenin for negative sequence is same as the Z Thevenin in positive sequence, which is equal to 0.2275 per unit for this power system.
For the zero sequence network, the impedance diagram need to be redrawn. As for the zero sequence network, all components in the network must be grounded. After redrawing the diagram, we can finally find the Thevenin impedance of the network. Since the fault occurred at bus 2, only the reactances that are connected to the fault will be included in the calculation, which means xg1, xg2 and xg3 are ignored. At last, the Thevenin impedance of the zero sequence network that is obtained is J0.1765 per unit. Since we have obtained the Thevenin impedance of all three networks, we can finally calculate the required faults. Firstly, the bolted single line to ground fault. Bolted means the fault impedance in the network is 0, and assuming the voltage source is 1 per unit, the single line to ground fault can be calculated using the formula given. After inserting all the related values, the value of the single line to ground fault obtained is equal to negative J 4.7506 per unit, or 4.7506 angle of negative 90 degree per unit in the polar form.
For my part, I will show you the calculation for bolted line-to-line fault. So first, we need to find the value of IA1, where the formula is EA is divided by Z Thevenin in positive sequence plus Z Thevenin in negative sequence plus ZF. So, but we need to remember that the value of EA is equals to 1 and the value for ZF in bolted condition must equals to 0. So after doing the calculation, we will get the answer of IA1 is equals to negative J 2.1978 per unit. So then, to find the fault current at line to line, the answer we calculated earlier is multiplied by the square root of 3, and we will get IF equals to 3.8067 per unit. Okay, next, let's see the calculation for bolted line to ground fault. So to find the fault current in bolted double line to ground condition, the formula that we will use is IF equals to 3IA0. But to find the value of IA0, we need to determine the value of IA1 first using the formula that presented in this slide. So after doing the calculation, we will get the answer is IA1 equals to negative J 3.0591 per unit. Then we can calculate the value of IA0, where IA0 equals to negative J 1.7227 per unit. With that, the fault current in double line to ground condition will be negative J 5.1681 per unit.